In one of the previous lectures, we understood what are the different components of Spark. In the low level, we have low level APIs. On top of that, we have structured APIs. On top of that, we have structured streaming, and we have advanced analytics and also libraries and ecosystems. These are the different components, or rather important components of Spark. Within the structured APIs, as we know, data frames are the important structured APIs. As a part of this lecture, we will try to understand what are the Spark data frames at a high level. We will come back to this data frames again and again because it is one of the important structured API which will be used again and again across the Spark. Then we will also understand what are partitions. Let's get started. So first and foremost thing is, what are data frames? Data frames are almost like a collection of rows and columns. We have already discussed about that. Okay. So, and we already indicated it is one of the important structured API. And also, if you really look at the whatever the columns are there, okay. So if we define the types of these columns, then we're calling it as a schema. Okay, the column names and also the types of these columns together we can call it as a schema, right? So this is what is data frame at a high level, and the schema also. Now if you really look at, we already understood data frame is nothing but a table like structure, and it's a collection of rows. If you see, we have 1, 2, 3, we have so many rows. So now it's a collection of rows and columns, right? These rows and columns are distributed across the different clusters. Okay, so some part of is distributed here, here, and also here. Consider this is a data frame. This whole thing is a data frame. So this data frame is distributed across the different systems in a cluster, right? So now, having understood the data frames at a high level, what are partitions? What is a partition in a Spark, in the context of the Spark? Any idea? We already understood what is data frame. So now, partition comes into picture, some set of rows in a data. See, we already know this is a data frame. Now, this data frame need to be split into smaller chunks of the data called as partitions. And these partitions will sit on the physical machine of our cluster. See, if you see, this whole data frame is divided into 3 partitions, and they are sitting in a different physical machine. This is one physical machine, this is one physical machine, this is one physical machine. But why do we really need to have partitions? As we know, we are in a big data class where distributed storage and distributed processing is very important. That is the central theme of the big data. Now, if you have a huge amount of data, if you want to process it, that huge amount of data at a one go, then it takes a lot of time. That is where we are trying to partition the data into smaller chunks so that we can do the parallel processing. So what exactly is happening is, this whole data frame is split into smaller chunks called partitions. These partitions are spread across these physical machines so that this will allow every executor to perform the data processing in parallel. Now that we are talking about the parallelism, we understood that partitions enable the parallelism in Spark. Means we take the huge amount of data, we'll split that into partitions. Those partitions are distributed across different systems. That makes us to do the parallel data processing. We are saying parallel data processing. Now, how does the parallelism work in the Spark? Let us try to understand that. Assuming that you have one partition, please pay attention. You have one partition and 1000 executors. 1000 executors. Any idea what would be the parallelism here? Can you pause a video and try this? The parallelism will be only one, because what is happening is the data on which the analysis need to be done, processing need to be done, there is only one partition. Even though you have lot of executors or physical resources, it doesn't make sense. That is the reason parallelism is only one. Let us take one more scenario. Okay, so let us say you have many partitions and also only one executor. What would be the partition? Can you pause a video and try? The partition is again only one, because in this case what is happening is the physical resource which need to be used to process the partitions is only one. It doesn't matter how many partitions are there. So because of that, again the parallelism is going to be only one. So let us take an example. So now let us assume you have how many partitions? Let us say you have 5 partitions and you have one executor. Any idea what will be the parallelism here? Can you think of? Again, the parallelism is going to be only one. Now, 5 partitions and then you have 2 executors. What would be the parallelism? It is going to be 2. So, if you see, whichever the smaller number here, that is going to be the parallelism. That is a kind of a trick, but you need to understand the logic why it is happening. So let us say now we have 10 partitions and you have 5 executors. What would be the parallelism? It is 5. I hope with these examples you understood the partitions and also how the parallelism works. Thank you.